many a time, dependent and independent variables. We've seen it in linear equations. When we have y equals 3x plus 4, for example, out of these two, which was the dependent and which was the independent?
Three is the
dependent.
Variable. 3 is the slope.
X is
So
X. Yeah.
whichever one you choose is you choose to get the other one is the independent. So if I choose, for example, I'm going to put numbers like -3, -2, -1, 0, 1, and 2 here. Who chose those numbers?
You.
I did. Okay. So whichever ones I can choose, that's the independent variable. Because it doesn't depend on anything. It's on their own. You can put whatever you want in it. But the other one depends on what you put in here. Right? So this one would be the independent. And this one would be the dependent. Make sense? Now, let's say that you have something like this. Which one's the dependent and which one's the independent?
Y is independent. X is independent. Y
X is independent and this. Now, what if I do this?
Why?
Why what?
X is dependent.
Because Y.
Why is it independent?
No,
Why is it
it's the
dependent?
dependent because you
Why
put the
dependent?
X's to get the Y.
Yeah.
Y depends on this. Okay? But if I do it this way,
X is the dependent. They go Y depends on you.
this one's dependent and this one's independent. Okay? So it's not the letter in itself that's dependent or independent, it's the position where it's in. This one depends on this. So this one's the dependent and this one's independent. Is that clear?
Yep.
Is that clear, everybody?
Yeah.
Fine. So, going to functions. A function, in general, this is not a definition you're going to find in the book. This is what I've, over the years, the best thing I can explain so that it's easy for you to understand. A function is a set of instructions or relationship, this being the key word, this you will find in the book. Relationship between an independent variable
and a dependent.
and a dependent variable. Between an independent and a dependent variable. Okay. Sorry. So, how do you express a function? A function is expressed, this is function notation.
Miss, we learned that like 2 years
I
ago.
know, but since you're asking, I'm saying it again. Okay. Function notation. Now, how do you read this? You say f of x. F of x. Now, we've learned that every time you see the of, it's multiplication, not with function notation. This is not a multiplication. Not a multiplication. Okay? Not a multiplication. What this is if I just give you f of x and give you nothing else, I haven't given you the function, have I? Because the set of instructions isn't there. I only have, it's just telling me that the function depends on x, but it doesn't tell me what that dependence is. But if I tell you that f of x, or g of x, or d of x, or v of x, or g of z, or y of x, or x of y, all of these are ways to depict the function, okay? It doesn't matter what letter you choose, and it's not always going to be x. Traditionally, it's x, but it could be any function. For example, velocity is v of t, because it depends on time, okay? So, if I give you, for example, v of t is 1/2 of a 32t squared minus 4t, I've given you the set of instructions. Which was the independent variable? The t. Which was the
B.
which was the dependent variable? The v, right?
Yeah.
Now, if I give you this, and then I give you v of 4, what do you do with that 4?
Substitute. The T.
I substitute
The T.
here, right?
32 times
Instead of
16.
4 squared minus 4, 4. Right? I'm going to change this 4 so it doesn't...
496. B equals 496.
Okay, but you see the point here. Yes?
Yeah.
Just wondering, but I remember seeing a question that says like V and then this is just like a random like Would this change anything or no?
Okay, yes. Let me say something. If I give you this information and then I ask for g of 4, what would you do?
Substitute again.
Into what?
Oh, the T.
You can't do anything. Why? Because I haven't told you what the set of instructions for g is.
It doesn't give you enough
Seth.
information.
So over here, there's not. You can't do anything because unless I give you what g of t is.
We need something T squared minus.
If I, you need the set of instructions. If you don't have them, there's nothing to do. Is that clear? Does that answer your question?
Q.
Q-Ho.
Yes.
Okay. So, remember there's a couple of things in order for something to be a function. And we saw this last year, but not functions. If x repeats in the order of pairs, for example. Remember these? The lungs?
Yes.
This is the domain, and this is the range. The domain always goes with the independent variable. And this one always goes with the dependent. Meaning, this is what you can put inside the set of instructions. It's your set of ingredients. This is the range, is what you get out of it. So if you, I like cooking analogies because I love to cook. But if you have a cake, your instructions are cake, okay? My domain is going to be what? Flour. All the flours I need, I can choose from. I can choose rye flour, corn flour, potato flour, corn flour, rye. There's so many things I can choose with the flour, right? Tapioca flour. What else? Eggs. It can be goose eggs, chicken eggs, and all those eggs. Vanilla. I can put rum. All of those are my domain for a cake.
Nice.
Notice that I never said chili peppers. I didn't say meat, right? Because that would not be a domain for
That would
cake.
be a range.
Unless it's a meat cake. And then if it's a meat cake, then meat goes in there, okay? That's the domain. And my range is not going to be a quiche, right? Because a quiche has vegetables. So, and I said cake. My instructions were cake. So my range is my result. It can be a cupcake. It can be, I don't know, carrot cake. It can be chocolate cake, vanilla cake, swirl cake. It can even be a brownie. But my range is what results from my domain. Is that clear? I can't, this depends directly on this. So I can't have something, this can never be a salad if I am putting in eggs and flour and chocolate and sweet things, right? This is not a salad, it's a cake. Is that clear? Fine. So, it turns out that if I can have stuff this way, right? And I can have stuff also this way. Meaning, I put in two 1 as a result. For example, y equal x squared. Look at it. I have minus 3, minus 2, minus 1, 0, 1, and 2. This would be 9. This would be 4. This would be 1, 0, 1, and 4. These start to repeat themselves. But this is still a function because the only things that repeat are the y's. I can get different types of cakes from the same ingredients. But can I get all different types of cakes from, no, can I get all the same cake from, can I get different types of cakes from the same ingredient? No, I need a variety of ingredients, right? So I can't do this backwards. I can't do it like this. This can't be done. Where I have all these different types of cakes and only 2 ingredients. That doesn't happen. That's not a function. That's not a recipe. It's something weird from science fiction. I'm sure you can do that in space like 3,000 years from now in some sci-fi movie, right? But you can't do it in reality. That doesn't happen, okay? So what they're asking, so that's what I mean when I say if x repeats in the ordered pairs, for example, 2, 3, 2, 4, and 2, 5, not a function. Because I have one single ingredient, and voila, I have cupcakes, brownies, and cake. How do you do that with just flour? It's like impossible, right? So this is not a function.
Not
But if I,
Can I get like
Can we get like
can you get 2 and 3, 3 and 3, and 3,
and
like
no
4 and 3? Absolutely. Because all these are different ingredients, and you get the same cake.
and 2 and 3, 3 and 5 and 4 and 3. Can I get it? Is that like a function?
What?
2 and
2
3,
and
3 and 5?
3 and 5, and 4 and 3. Yeah,
Yeah.
that could be it. That's a function.
You get different ingredients and you get different cakes. Yeah.
Maybe it's
And
the
Yes.
same.
sorry,
what if
can I
they-
get? Can I sorry? Can I get
Can I
2, 3,
3,
2,
4.
5? No,
Just
that's
ordering
not
food?
no. Sorry.
Repeat
2, 3.
2, 5.
No. Yeah.
You got it?
Yeah.
You see that there's only one.
Miss, wait, miss. If the first
put 2, 3,
2
2,
repeat,
4,
if the x in the
if it's in the same
parentheses
person.
repeats, that's not a function.
No.
But if it repeats in the y, it's still a function.
Oh.
So that's how we know if it's a function or not.
And like I said, the best analogy I
If it
could give you is
repeats
a
in the
cooking
X, it's
analogy.
not. If it repeats
You
in the
can
Y,
get
it's a function.
A bunch of different things from a bunch of different ingredients. That's no problem. And you can get the same thing from a bunch of different ingredients. But you cannot, it's impossible to get different things from one single ingredient. It's just not possible, right? So that's why it's not a function, okay? So are we clear on this?
Yeah.
And that's it?
Woo!
Peace sign.
So that's
Please sign.